Let's take a look at auditing of wireless networks. Wireless networks are used extensively today in, well, everything from laptops to mobile phones. We have, of course, satellite communications, which also, of course, can be used both for phones as well as for, of course, networks, wide area networks. And we have then microwave. In fact, at home, that's what we have to use because I'm a distance out in the country. We then have the ability to have a microwave link. Now, the difference, of course, is that things like some wireless communications are line of sight. Satellite and microwave are both like that. You must be able to see that the two destinations must be able to see one another. Whereas something like a wireless local area network in your house is something that is not line of sight. You just have to be within range of that radio signal. So taking a look then at wireless networks, we have the entire IEEE standards known as 802.11. And there's a number of different standards related to this, of course. There was the 802.11b, which is the first one that came out. And it came out specifically for like home use, kind of a cheap, unreliable wireless communication, operating the 2.4 gigahertz band. Now, the significance of that is we have three bandwidths that are often used for what we call industrial, scientific, and medical bands, or ISM bands. 900 megahertz, 2.4 gigahertz, and 5 gigahertz. And 802.11b operates in that 2.4 gigahertz band. Now, the problem with that is so does a lot of other equipment. And therefore, you can easily get interference with a wireless signal operating within that bandwidth. You also have things like 802.15 Bluetooth operating in the 2.4 gigahertz band as well. But out came B. Certainly a good enough product. Shortly after that came out then the professional quality 802.11a. And this is operating in the 5 gigahertz band, which gave it, in many ways, much better speeds, from 11 up to, of course, 54. But the problem, of course, a shorter range. And, of course, there's been a lot of developments in this area, 802.11i, 802.11ac, and, of course, some tremendous speeds we're getting now with the wireless networks. And these are usually used then in wireless local area networks. You then have the IEEE 802.15. This is usually used in, of course, wireless personal area networks, and the most common implementation of that, of course, is Bluetooth. Very short range, 10 meters, 30 feet. The idea behind Bluetooth is that you're just able to communicate between two devices that are close to one another, and because it operates as well in that 2.4 gigahertz bandwidth, one of the things it utilizes is what we call frequency hopping spread spectrum. In other words, the signal bounces between different frequencies. So that if one frequency was, for example, quite noisy, you'll only be there briefly before you move off anyway. And so you try to get away from that problem of congestion just by moving quickly between frequencies or channels, we could say. And then you have something that's often known as WiMAX, wireless metropolitan area networks. And this is used in a number of cities where the entire core of the city has wireless access. And anybody in that area can have wireless and they can communicate and so on using that, and often called a connected city, 802.16. One of the problems is that a wireless signal can be picked up by anybody in the area. So therefore, we need some type of wireless local area network security. And the first attempt at this was known as WEP, Wired Equivalent Privacy. And WEP was a valiant attempt, but didn't work. Quite simply, it suffered from the problem that the initialization vector, or the random value used in the encryption, was just simply too short, which meant that it could, given a little bit of manipulation, you would actually be able to guess what the key was, and you could intercept and read the traffic. So when that was really proven to be breakable, we saw the release of Wi-Fi Protected Access, or WPA. Now, WPA was only an adaptation of web. They both still use the same algorithm, RC4, but it tried to use what we call temporal key integrity protocol, and it also, of course, then used a little bit better integrity checks from the perspective of something we called Michael, or message integrity code. Now, it was only meant to be temporary until the release then of Wi-Fi Protected Access 2, which is completely different. It uses a completely different protocol. It uses the encryption algorithm of the Advanced Encryption Standard. And it uses two modes of AES. It uses one to do the encryption of the traffic, and that's what we call counter mode. And then it uses another one to do the integrity, and that's what we call CBC MAC. So you quite often will see WPA2 written as AES-CCMP, which really stands for Counter Cipher Block Chaining Message Authentication Code Protocol. It's a fairly good, secure implementation of wireless local area network security. As with anything else, it depends on choosing good passwords, so you don't become susceptible to things like a dictionary attack. Now, what it also does for us is it provides both the confidentiality and the integrity of our traffic, which is, of course, important. One of the risks we always have is somebody setting up a rogue wireless access point. Now, this can be done with certainly wireless 802.11. It has also been done with mobile phones. A person may set up a fake cell tower that all the phones in that area connect to instead of to the regular telephone network. In either case, the result is the same. By setting up either a rogue wireless access point or a rogue cell tower, the person is able now to intercept all of the traffic that is going through those networks. Now, on top of that, of course, one major risk is people putting in wireless access points that are totally unsecured altogether. So you actually have now wireless access points that, well, often we call this open systems authentication. And the problem, of course, with an unsecured wireless access point is that anybody in the area can be picking up the traffic that's communicating between any tablet, any laptop, and the wireless access point itself. We also, of course, have our good friend, the web. The web runs on top of this infrastructure we know that's called the internet. Now, of course, some people think they're the same thing. They're not. Actually, the internet is the fabric. It's the communications infrastructure, whereas the web is an application that runs on top of that infrastructure. It's kind of like the idea here is that the web allows us now to, well, it's one of the many ways we can use then the internet for communication. The way that we communicate on the web, of course, is using things like URLs. We use a URL such as www.pluralsite.com. And the advantage of this, of course, is that we have a standard format structure that gets converted using something we looked at earlier called then DNS into IP addresses. And this means that we have an internationally recognized type of then communications infrastructure around the world through the allocation of IP addresses and URLs so that we can communicate even though we're often using different languages and different character sets and so on. Now, some of the things used then to make the web work for us. If you do, a lot of the banks still use CGIs, Common Gateway Interface scripts. So when you go to log into a bank, when you actually click on sign in, you're actually then executing a CGI script. You're telling that server, please run this script for me and do this task. Allow me then to sign in. And that, of course, is one of the ways that a browser out anywhere in the world can talk to a bank's head office and talk to their web server and be able then to initiate a login process using a CGI script is one of the ways. One of the things that also this is used for, of course, is to be able to track our activity. We quite often, websites will put cookies on our system. So that, let's say we have a website that might offer services in various languages. You take a news site, for example, like CNN, that you could go look at the CNN international version, or you could look at the US version. And the idea of putting a cookie on your machine means that when you go back to that site in the future, it'll take you back to what your preferences are. You don't have to re-choose whether or not you wanted English, Spanish, or French. You don't have to choose whether or not you want the local weather in Tulsa, Oklahoma, or the local weather in New York City. It automatically will have stored that, and then, of course, through that cookie, know that that's what it should, of course, display for you. There have been a number of attacks related to use of applets. Applets are portable, risky programs written in Java, JavaScript, or ActiveX that could be used to take over or execute undisciplined code on our systems. These have often been used by hackers to steal identity information and other information from an unsuspecting victim. So protocols. Protocols are the agreed-on format for communication. They are the languages of the internet, such as FTP, HTTP, Simple Mail Transfer Protocol, Internet Protocol. Many of these different languages we use. And they allow us to then take millions of bits of information and break them into individual pieces so that a person at both ends understands what that other person is trying to communicate. Now, some protocols, by their very nature, are insecure. Others tend to be more secure. And the idea here is that where possible, we should try to ensure that we are using more secure protocols. Use HTTPS much more often than just HTTP, for example. Use secure FTP. And these are some of the ways that we can then try and protect our internet communications as well. So let's take a look at network security. Network security starts with knowing what's happening on my network. Taking a look at the logs and monitoring and realizing, do we have breaches? Do we have possible problems that we need to be monitoring and watching? We need to make sure that our networks continue to operate with high availability. This means we bring in concepts such as fault tolerance. Even if somebody attacks, yeah, it's fine. We have ways then to be able to continue to provide service. Some of the attacks we've had, distributed denial of service attacks. Well, do we build in the ability to withstand that attack and still be able to operate, for example? Do we build in load balancing? Do we build in failover capability? But one of the most important areas of all of this is configuration management. Configuration management, where I make sure that all of my network devices are properly configured. I make sure that they've been hardened. We turn off any unnecessary ports, protocols, services, administrative interfaces, administrator accounts, and try to disable anything that could be a possible attack vector leveraged by an attacker. As auditors, we need to know how to audit networks, and we're going to check the configuration. We're going to make sure that firewalls, switches, and other devices have been configured and hardened correctly, that the rules have been documented and we have the right rules in place. We're going to make sure we have adequate capacity of our, say, bandwidth to be able to support the business requirements. We're not going to have a unreasonable delay in response time because, should we say, inadequate planning for peaks of traffic, for example. And one of the things we should always test for, does our IT management ensure that we have staff that is adequately trained to manage then their systems effectively? It's really important here that we have the training, that people know how to manage various network devices, for example.